In previous video, we have learned how to create a binary tree using a queue data structure. Today in this video, today we are going to learn um, how to write a program in Python language to implement our binary tree. So let's see, for the first time we have to create a class for creating node. And we will have a constructor div. Here will be double underscore for init, but I'm here using only one underscore. Okay. Self and data, and we are going to initialize them as self dot data is equal to data. Suppose this is the data. Initially left side and right side will be none, so we have to initialize them. Self dot left is equal to none, self dot right is equal to none. Now let's create a class for binary tree, that is class binary tree. And for self root node, we're going to create another function, that is def init. It will take only one parameter, that is self, and we are going to initialize root node for the first time. Initially our root node will be none, so we have created two classes, that is for node and that is another is for binary tree. Now let us define another function. All right, algorithm. We are going to devise an algorithm to implement our binary tree. For implementing a binary tree, we have to implement first an algorithm to insert node into our binary tree. So we are going to define, we are going to name this function as insert node, and it will take two parameters, that is self and another is data. Now create a new node, using which class? Using this class node. So that will be node, and how many parameters is going to take? Only one parameter, that is data. Okay, now we have created a new node. Now let's check our root node is empty or not. If it is empty, then we are going to assign new node to our root node. Suppose we are going to check using a condition like this: if self dot root is equal to none, then our self dot root will be our new node. It will be our new node. Fine. Else, now we should return if it is our new node. Else, if our root node is already existed there. So here we appended our self dot root into our queue data structure, and then we are going to check if the root node is existed, if it is true, that is while true, then we are going to pop out this address and we are going to create a temporary pointer t. So the node is equal to q dot pop, because 0 is for index, that is very first address we are going to pop, that is 0. After that, again we are going to check if the left child and right child is existed. That means if it is not none, then we are going to check like this: if node dot left is not equal to none and node dot right is not equal to none, then if node dot left is not equal to none and node dot right is not equal to none, then we are going to insert this left child address and right child address inside of our q data structure. That is q dot append. What we are going to append, that is node dot left, again q append, this time for node dot right. If I'm going to write here the next part of this program, if node dot left is there and node dot right is there in our binary tree, then we are going to perform this function, this line of coding q dot append node dot left, that we are going to insert in our q data structure, and q dot append that is going to insert our node dot right into our q data structure again. So if it is no left child and right child is there, so what if there is no left child, there is no right child? So we are going to check this condition also, else if node dot left is equal to none. If left child is none, then that node dot left will be our new node. It will be our new node and we're going to append this node dot left into our queue, that is q dot append node dot left, this part. Else if left child is none, now it is for if node dot right is equal to none, then our right child will be our new node. Node dot right is equal to new node, and again same procedure, same step, we are going to insert that address of this right child into our q data structure by writing this line of code: q dot append, what we're going to append, node dot right. Now there is our while loop, so we have to we have to break the while loop here. After the here, after the step that we have written before, now it will come up out of the loop and it will perform this type of steps, and finally we will have this type of binary tree. So that's all in this video. We have learned today how to implement a binary tree using Q data structure in Python scripting language. In next coming videos, we will be learning about a tree traversal. There is a pre-order, post-order, level order, in order traversal. So we are going to learn one by one gradually. So that's all for today.